Okay, so here's some example problem. Question number one, you have a clay site, normally consolidated clay, and this clay layers was placed a sand few layers on top of it. So this is like a mammically placed on the clay layer. So now once you have this few layers, the question asked, how much settlements would you expect? So this is a very classic settlement problems asking you the questions of how much. When you see like, find settlements in terms of how much, when you go to the FE menus, we can automatically think of those three equations, which like there's three equations right there. The ones that give you like the amount of settlements. But realize that you have three scenarios. You need to pick one. And if you go back to my previous lecture videos, I touch base on how to, periodically, how to determine which one to pick based on different loading scenario. And for more details, you can go back to my C366 lecture series, lecture 8. And I will get into more details on how to come up with those equations. But anyways, now like you have FE exam questions and due exam times, so your time constraint. So you want to start with the equations, but now the question is which one is the one that you need. And if we go back to your questions, there's a keyword right there for this particular questions, normally consolidated. Since normally consolidated, which means the soils is at a stress level that beyond its maximum pass pressure. So with our understanding on the soil mechanics again, this is the maximum pass pressure, P sub C consolidation pressure. And whatever pressure greater than that, you will be at the C sub C region, the compressions, so the virgin compressions regions. Because of that, we know that, go back to our FE menus, for this normally consolidated clay scenario, we will pick this equations that only has C sub C. So again, that's a keyword, especially exam time. You want to save your time. Well, whenever like you see a normally consolidated clay, you automatically think of this equations when you're asked to find these settlements. So the settlements equals to H naught divided by 1 plus E naught times the C sub C times the log P naught plus delta P, and then divided by P naught. And now you got the equations. You need to figure out each terms of it. And this equations again is just directly from the FE menu. One more time, it's exactly this equations right here. Okay, so first term, H naught. So H naught is equals to the thickness of your clay layer. So this time is 8 feet. And 1 plus E naught. And E naught is not given in this equations, but it is given by the T sub S and also the water content. So whenever you're asked about water ratios, and you realize that the questions give you the specific gravity, G sub S, and water content, automatically think of these equations. So the George Washington's is a soil engineer. So G sub S is the specific gravity, W here is the water content, and S is the saturations. And when your clay is under the groundwater table, pretty much you can assume this is like a fully saturated. And now you just solve for the water ratio. So the water ratio is equals to the G sub S, 2.65 times the water content. which is 50%. So you solve for that, the void ratios we got will be 1.325. So this is 1.325 right there. And the next is the C sub C. So C sub C is not given again, but you realize the equations give you the liquid limit. So you require you to realize in the FE manual. So it's always good to study your FE manual before the exam to prepare yourself. Remember, like in FE manual, there's two equations here quite handy when you come with the C sub C and C sub R. So C sub C is the compression index, C sub R is the recompression index. For C sub C, it's just this equation right here. It just correlate with the liquid limit. So whenever you have settlement problems for the questions of how much and when you given you the liquid limit, pretty much is give you a hint. You need these equations to convert or to correlate the liquid limit with the compression index, which you need for your settlements analysis. So for this case, the C sub C, we can calculate based on the liquid limit. So C sub C is equals to is 0.009 times the liquid limit minus 10. Again, equation strictly from the FE manual. We plug in the liquid limit, which is 42. And we can solve for C sub C is equals to 0.288. So we got our times log, and the now the remaining term is the P sub naught and also the delta P. And P sub naught is the stress, the original stress before the placements of the field to the midpoint of your clay layer. So it's a stress here. P sub naught here. And P sub naught will be equals to the gamma Z minus the pore pressure is an effective stress. So you take care of the pore pressure, which is equals to 110 pounds per cubic feet times the depth will be half weight at the midpoint, so it's 4 feet, and then minus the water pressure, 62.4 pounds divided by cubic feet, which is the unit weight of water. So this is the unit weight of water, and then times the depth is again is 4 feet. So the depth from the groundwater table, which happens also is the original grade level for the clay layer. So if your water level is not happen at the interface or at the grade level, then you need to be careful on the what is the water depth. So calculate this P sub naught will be equals to 190.4 pound per cubic feet. So we got the P sub naught, and beware that the units can be all cancel out on this fractions. So that's why I'm not putting the units there, but you always a good practice that you always include the units. So especially important for exams, because it helps you to eliminate any like careless mistake, and also like you could end up like a save your time if you be careful on how the units work out. So we got the P sub naught, and the delta P is the loading. So the loading pretty much is the placements of the field layers. So it's delta P is equals to the unit weight of the sand, 125 pound per cubic feet. This times the thickness. So it gives you the stress. So the stress that put on the clay layer. So this one is 250. This is 250. And after we calculate all this, we plug in the equations, and what we got the settlement here. So this should be the settlement. This equals to 0.361. Again, we keep track of the units. Everything is canceled out except the feet from the H naught. So it's 0.361 feet. Also equals to 4.3 inches. So this would be the answer. So question 2 here said, there's a normally consolidated clay, which is 15 feet thick and has a weak compression index, which is C sub R is equals to 0.05, and the void ratios E naught is equals to 0.26. And this clay or this soil is subjected to a new constructional load such that it caused the soil effective stress to increase by 115%. So now it's just asked what is the soil layer settlements. With that, like increased by 150%, which here essentially means the final loading is equals to 1.15 of the original loading. And just ask the settlements one more time, since we got the keywords here normally consolidated. So you know that you can use these equations like the previous example. Again, directly from the FE manual, the delta H is equals to the H naught 1 plus E naught C sub C times log the P naught plus delta P divided by P naught. So this again is directly from your FE manual. It's just the equations again for you to calculate settlements. And since we know it is a normally consolidated clay, so it is the scenario that all the stress pass through the P sub C, P consolidations or maximum pass pressure, and all the settlements activities happens at the virgin compressions region. So that's why we pick these equations. Again, like next, we plug in all the informations. So the H naught for this case is 15 feet. So this is equals to H naught. And 1 plus the void ratios, this time is given 0.26. And C sub C, now what is C sub C? The questions didn't directly give you C sub C, but you give you C sub R. And we go back to our FE manual. In fact, it gives you the correlations, another correlations that it's always good to study ahead of exams. You realize there's equations that correlate C sub C and C sub R. So when you give a C sub R, which means you can estimate C sub C based on these equations. And they are 6 times difference. So it's a very rough, against very rough equations. It works for your FE exams, but in practice, I realized that those correlations may only work for certain type of soil, but not every kind. So in practice, it's always need to double check what kind of correlations you go into, or what kind of scenario or application limit of the particular correlations before you use it. But for FE exams, we can move on with the equations. So the correlations say C sub R equals to C sub C divided by 6. So now we know the C sub C will be equals to C sub R, this case 0.05 times 6. So the C sub C equal to 0.3. So this is 0.3 logs P naught plus delta P divided by P naught. We know this one, actually, this one here, P naught plus delta P, that is the final stress, because this is the initial stress plus the surcharge or any kind of loading. and then like I give you the final stress. So pretty much this is a ratio here, and the ratio is given because the equation said the soil effective stress increased by 115%. So we know the ratios is 1.15 between the final stress to the initial stress. But this is not 1.15. So plug in all the informations, we get the settlements for this question is 0.63 feet. Equals to 7.55 inches. So this is the answer. Okay, the third question here, given you a soil profile, you have again a normally consolidated clay, give you the C sub V values, so which is the coefficients of consolidations, equal to 0.046 feet square per day. And you realize this clay is like a sandwiched by two sand layers. And the questions here now ask you the time required for settlements at 1 inch, 1.5 inch, and 2 inches, provided that the total settlements is 2.8 inch. So if you wait like an infinitely long time, will be equals to 2.8 inches. So if you wait a long time, it will be 2.8 inches. But now the questions ask you, what is this, how long it takes to get to like a 1 inch, 1.5 inch, and 2 inches settlements, given that you know the C sub V and also you know the ultimate settlements. So this is a question of how fast or the time rate of settlements. When we ask that by the time rate of settlements, there's already good start on the FE manuals. You know, the second part of the FE manuals, this part is related to the time rate of consolidations. And this Tosaki equations here is always good to start your question, to solving your questions. So let me put down the equations there, which is the time factor equals to the C sub V times the time divided by the drinkage path HDL squared. And you asked it for the time, so if we reorganize the equations, the time equals to the P sub V times the HDL squared divided by C sub V. So the first part is ask you how long it takes, how much time it takes to get to 1 inch settlements. So 1 inch settlements divided by the ultimate settlement, which is 2.8 inch. You can give a ratio, which is equals to 36%. And if you look at these equations right there, you want to know about the percentage of consolidations, because in the FE manual, if you know the percentage of consolidations, then you can find out the time factors corresponding to that. So it's using this table here, the time factor with different degree of consolidations. So if you know like the percentage of consolidations, you can read the factor of time factor of T sub V, and which you need to solve for the time. So at 36%, we have a time factors of 0.0102. So we will use that for our calculations. So we know that the time factor, so for the time to reach 1 inch settlements is equals to the corresponding time factors 0.102. Again, we read it from the FE manuals, and now it says drinkage path. The drinkage path depends on the degree of drinkage. And in this case, since our clay layer is sandwiched by two more permeable soil type, sand. So we know that the water can go either up or equal down. The excess pore pressure can escape either from the layer above or the layer below. So the longest distance now you make the drinkage path will be the half of the thickness of the clay. So this is our HDR, the drinkage path. And that is like a 4 feet. Again, always good to put down the units. And C sub V is given 0.46, so 0.046 feet square per day. So you see how the unit cancel out. You plug in the equations. So to get to 1 inch settlements for this site, we calculate this as 35.5 days. So similarly, for 1.5 inch, similar procedure, we want to know the percentage corresponding to that, which is like a 54%. So at 1.5 inch time, how long it takes to get there? We know this is correspond to 54% of consolidations. And if we go back to our menu again, and we have the 54%, which is like a 0.23 right there. So this is 0.23, same drinkage path again, same C sub V coefficients of consolidations. And we do our math, this is corresponding to 80 days. And for the case that we have 2 inch settlements out of ultimate settlements of 2.8 inch, that corresponding to 71% consolidation. So that is, according to our menu again, 71%. Right here, the time factor is 0.417. So plug in the number here, 0.417 for the time factor at 71% consolidations, and the same drinkage path distance. C sub V again, always put the unit to remind yourself you're doing the right thing. And after the calculations, we get 145 days to get to 2 inch settlements for this site, for this soil. So for the next questions, pretty much it's the same. It's the same questions, but the only different now is instead of like sitting on another sand layer, our clay deposit is sitting on overly consolidated clay. So which means the clay there is relatively impermeable. Compared to the clay layer on top of it. For that case, our water can only escape from the top. And the longest drinkage path is the whole thickness of the clay layer. So this is the only difference between this questions number 4 versus the questions number 3. Now we have a single drinkage scenario, not double. And for this case, it asks you again 1.5 inch settlements, how long it took to get there. So this very similar procedure. So we have 1.5 inch settlements relative to the ultimate 2.8 inch settlements. This gives me 54%. Same thing. Now we want to get the 1.5 inch settlements, but at a single drinkage, we put in the numbers. So at 54% consolidations, we read our FE menu again. This corresponding to a time factors of 0.23. So we will put 0.23 back in our equations. And same C sub V, which is 0.046 V squared per day. But the difference now is we have a single drinkage, not double drinkage. So the HDL this time change to 8 feet. And we do our math. We get to the 1.5 inch settlements. This time you get 320 days. So you see, like when we have a single drinkage, in fact, it will take a much longer time than you have a double drinkage. Last time, we only take 80 days to get to 1.5 inch settlements out of 2.8 inches. But when the drinkage change, when you only have a single drinkage, then in that case, from 80 days, it increased to 320 days. Again, thank you all paying attention to all these examples. I will find other more details examples coming up for my next YouTube clip. Please share and subscribe my YouTube channels for more FD exam prep tutorial.